All right, on to number 4. Plan for today is to build objects that we can work with. So as you just load up our default script, as you get more and more complicated scripts, stuff like this, free RAM equals ns.getServerMaxRAM minus getServerUsedRAM, it becomes very wordy. Probably even more annoying is stuff like getServerMoneyAvailable is less than getServerMaxMoney. Because to me, it should either be getServerMoneyMax and getServerMoneyAvailable, or getServerMaxMoney, getServerAvailableMoney. You know, it would there would be some kind of pattern to it where you could be like, oh yeah, I remember how to write this. Anyway, that's kind of a tangent, but there's a function called getServer. And I'm just make a new file. GetServer works like this. Let's go on and print that out. Oh, maybe don't typo your names. Looks like that. Basically returns a bunch of really interesting and useful information. Do we have admin rights? Do we have, what's the max RAM? Do we have enough ports open? Server difficulty. This is get server level and get server min level, min security level. Money available, money max. Ports required, ports we got open. Used RAM. Like all of these come together to form essentially a profile of a server, an object that represents the server. But like I was describing earlier, I hate how disorganized some of these functions and properties are, like RAM used versus max RAM. Why not RAM used and RAM max, or max RAM and used RAM? Just give me something I can actually remember how to type in the right order. What I like to do is build a custom object. Oops. And to do that, we're going to put it in a class. So we're going to do class server. I just want to call it base server. And we're going to constructor. We're going to create a constructor. This is basically how you define a class in JavaScript. Say this.ns equals ns and this.id equals hostname. And you'll see why I'm doing it like that in just a minute. But what this means we can do is we can do a new base server ns food and stuff. And then we could even like print this. Let's actually print something out, print out the ID. See, there we go, we get food and stuff. Now, where this gets really powerful is when you define a bunch of things about a server. So I'm going to copy and paste stuff to start with, because there's a lot of typing. But I'll go back through and explain it all at the end. All right, there's your base copy and paste. What we're doing is defining a bunch of properties using the get keyword that makes them getter methods. What that means is that normally you would have to call a function with braces, like base server.id. You have to do something like that. By putting the get keyword in front of it, you just do this. It's assumed to be like a property style variable rather than a function, even though it is a function when it's defined. This just makes referencing things very, very easy. So now we've already done new base server food and stuff ID. Now that we've pasted all that stuff, let's do .money max. There we go. 550 million is the money max of food and stuff. And we've got all these properties just ready to go. So we can let s equals, this would be kind of how you define it. And then if I wanted to mst print a bunch of different stuff, s dot money dot, top one we'll do available, then we'll do max, and we'll do growth, which are 3 different properties I've defined on it. There you go, available, max, and the growth level. So now that we've got this, we could do a few other things. One thing I'm going to go on and do now is define a list getters property or method. You don't exactly need to know what this does. It's a method that will allow us to later get the values of all of these getters. It cycles through the object, gets its property descriptors, which are these guys. These are the properties. And then for each, it adds them to a set. And what's interesting is if you remember the dp list function we wrote earlier, look at that. And look at list getters. Same basic structure, instance properties, current set, and then the set. For each, we add it, and then we call it recursively. For each, we add it, and then we call it recursively, return this dot list getters, which is the same function. So essentially the same structure, a recursive function. But all the source is available on the GitHub. So I would say just go and grab it off of that. Then I'm going to add, let's see, there's one other, this right here, reserved home RAM. So you know how when we type a script, a lot of times it's like, can't run this because you don't have any RAM. That's because we're not reserving any RAM. Now we are. So what this will do is when we call ram.free, for example, it'll do the standard math. It'll take this data, max RAM, so max RAM minus RAM used, but then it'll subtract if the host name is home. So if we're calling this on home, it'll subtract reserved home RAM. So it will consider reserved home RAM to already be used in any calculation that asks how much RAM is free. Right, so those thread counts that we did earlier, they'll assume that you've already used 20 gigs of your RAM, and they won't ever impinge on that RAM. That means you can still run scripts, you can still do stuff while you're executing your hacks. And probably, since I've only got like 32 gigs, I'll probably shave this down to 12. Right, so now I want to define this thread count function. I'm going to copy that and paste it here. Take off the function keyword. Don't need host name anymore because we know the host name. It's the server that we're calling it from. And we don't need this ns_get_server max RAM anymore because it's going to be this ram.max. We don't need used RAM anymore because it's this .ram.free. But remember, we already defined free RAM up here, ram.free. So we don't even need this. We can just be like this .ram.free. Done. Don't need to send ns in. So it's just thread count script RAM. Now if we come down here and we want to stprint thread count, or sorry, s.thread count, with a script RAM of 1 gig for food and stuff. Tells us we've got 16 free threads, which makes sense because it's got 16 gigs and nothing's running on it. Now, how are we going to use this like in the real world? Well, we're not going to need this main function for one. We're going to use base server. We're going to import, let's see, did I export that? I need to export it. Export class base server. We're going to import base server in go.js. So at the top of the file, there we go, and that looks like it's going to import fine. And anywhere we're doing this kind of crap, so we won't need thread count anymore. Like this would be a good place to do it. Let servers equal dp list. I might change this to let s list equals dp list, and then for s of s list new base server, since we're passing the host name, and we'll make another array, and then servers.push new base server. So essentially, after this little slice of function runs, servers will, instead of being just an array of server host names, it will be an array of server objects. So we can operate on those server objects with more capacity than just the server name. So for example, let's server of servers. The parameters for SCP are still, you're still sending the files, still setting home as the source, but for the server, you're going to see server.id. Why are we doing server.id? Because we defined server.id as this.id, which was the host name, which is exactly what we passed into the function here to create the server object. And here, has root access. We don't need that. We can do server.admin, which is the function we defined here. Return this.data.hasAdminRights. That tells us if we're admin. So notice what's happening to the RAM count, the RAM size as we do this. As root access target. That would be, wait, where did my target go? I think I'm using an old version of the script or something. Yeah, this is from episode 2. Okay, hold on. I guess it's not. We just never actually changed to use all targets. Okay, so we'll keep it like this. So right now, target is just a name, just a string. We need to convert target into a server. So we can do let target equals new base server in S, food and stuff. Now everything works the same. We can do server.admin, then we can do target.admin. We can do target plus security dot not max level, which is what we defined over in the server. Get security returns level and min. Let available threads equals server.threadCount. Remember, we defined a function thread count past the script RAM. See how this is already getting shorter and easier to read. If available threads greater than or equal to 1, nsexec. Okay, so this will have to become server.id, target.id, and target money is target.money.available. And max money is target.money.max. See, it just makes sense now. Server.id, target.id, because we only care about the host names here. Same for all of this. .id and .id. Oh, and I was going to point out, before we started, we were at 6.4 gigs. Now we're at 6. And just make sure that we've gotten everything out. Yep, that looks good. Now we're just being charged 2 gigs for get server one time. And that works for all the information we would ever need about a server. So let's run it and see if anything happens. Yeah, exactly what we wanted to happen. Nothing has changed. Our code has just gotten cleaner. Now we're going to do the same thing for get player. Yeah, a lot of copy and paste. All right, so this creates a player live, constructor NS and ID, same as with server, same list getters. ID does the exact same thing. Data returns this .ns.getPlayer, which is the same as libserver, where data returns this .ns.getServer. Get HP, this .data HP, so we'll have an HP property with current and max. We'll have level, money, intelligence, class name, company, blah, blah, blah. We'll have Bitburner information, create program, all of our work information, all of our stats, and it's organized now, dexterity.level.exp.multipliers. This is our general hacking level, so player.hacking.level. We can even do like 2 next level. Player.hacking.tnl will give us the experience required to hit the next level, and this is hacking level over here. Some hacknet multipliers, market information. Do we have stock market access? What level of access do we have? Ports. How many ports can we open? So we run an ls on home for files that are named one of these names, and we get the length. And then we do the same thing for get software to get specifically which softwares we have. That means we can just do like player ports and get an integer like 3. Okay, we got 3 ports. That means we can open any servers with less than 3 ports required. But then if we want to know, do we have the FTP software, we can call player.software.ftp. And the cost of this, just half a gig, and you get all this information about the player. Oh, so where would we go from here? I don't really want to mess with the hacknet scripts because they're pretty locked down. Max cache I'll leave like it is, just so as I don't confuse the fans. And we're not using player yet, so that'll have to wait until next time. Here's what we could do though. This piece of code here. Else open all possible ports on every server. We come back into base server, I'm actually going to subclass this into a different file, and you'll see why later. But I'm going to create just going to call it libserver hackable.js. And in this, I'm going to import base server. I'm just going to extend it, add my constructor back in, call super. Then I'm going to add something called sudo. It's function. And this entire block of code, right? The whole point of this is it gains root access to a server. But instead of passing server ID to it, I will just say this.id. And now, save that, head over to Go, delete all this, and just do server.sudo. So we've essentially we've partitioned out our code so that things that have to do with a server, like gaining admin access to it or checking its money, all lives inside this base server class. It doesn't live in the script. The script is for logic. It's like, this is what we want to do with that information. But if we know what we want to do is gain root access, that can live in server, in the server object. So we'll just kill all, run Go again. Base server is not defined. What? I gotta figure out what file layered. Oh, I know what it is. Gotta change your definitions. There we go. Everything's running exactly like we wanted it to. All right, so we've refactored the server and player objects, which is going to allow us a lot more power to kind of implement logic that's self-contained. That's really a good pattern for coding. And if I was you, I'd probably turn this video off now. But I'm going to do one more thing, which you don't have to do, but it's something I like to do. And that is a cache. So I use the database, which is part of like the browser. It's part of the game. It's called IndexDB, index database. I like to store information about the player and the servers in that database so that I can like view it from the debug menu and stuff. And the function to do that is this right here. And this is for player. And this is for servers. Don't worry too much about what this does. This will be in the GitHub. Like this is just another function that you just kind of trust to do what it does. But what it does is it updates the cached data every 60 seconds. That's it. So I got to add this to all of the functions. So there's the player. And then I have to do a slightly different one. on the hackable server. And you'll notice the difference between hackable, which is a subclass. It extends a class, and the base class. There's a key difference here. So in libserver, we're actually pushing the data into the cache. But on these subclasses, we're not doing it. We're just super update caching. So we're calling the parent to tell it to cache. And this just keeps you from writing to the cache. You know, if you're 6 levels deep in an inheritance chain, you don't want to write 6 times to the cache. You just want to write once. But you got to get that data to the place where you're going to write it from. And the place I write it from is the parent class. So it's going to have nothing to do with you. You don't have to implement this unless you really like the idea of doing this. I'm not going to do. Let's put it in Go. So up here, what we're doing, we're creating this list of servers. Something like that. Oh, of course, I forgot to make handle DB. Once again, you don't need to know anything about what's going on here. Just function we're using. And all we got to do is import. And we'll do that on both server and player. So what? You'll notice that there's already a Bitburner save. This is where your save file gets stored at. There it is right there. That's your save string. Copy that, export it. What am I missing? Lib server. And that looks like it should work. Oh. No, I don't have to pass that in. I think maybe I just didn't save all of my files. I'm really confused. That should be working. I don't want to change that. That should be working fine. Yeah, it's being created. I wonder if it's that. Did I miss something in my copy and paste? I don't think so. I'm going to copy and paste it again just in case. I'm also going to refresh it. If I can chase down exactly what server is causing the error. The first one, noodles. And this is completely useless. Let me. Okay. So it's something to do with this hackable base server, because that worked fine. And if I open up Phoenix OS, you'll see the list of servers here. There you go. Boom, they got all the data. Anyway, you can expand it. You can look at like the RAM. I see Blade has 64 max RAM, 64 free. I can see the ports required 5, open 2, and so on. I don't think that's it. That was it. Maybe it has something to do with the try catch. Never actually done this in this form before. Thinking because, well, that works. I was thinking because maybe it was like a static something or other. I don't know. I literally changed nothing and it worked. I changed absolutely nothing. I think it just didn't save. Commented it out and commented it back in and saved it again, and it started working. Yeah, sometimes you get bugs like that. And while we're here, let's just go in and do the same thing with player. And we should see in just a second. Yep, there's our player information. So what do we know? We know our HP, any companies we're working for, our charisma, our work, our crime, basically anything that we could want to know about the player, we know now. So the entire set of data provided by the game is now accessible to us in our scripts and in our database. Let's see. I think I'm gonna do a little bit of cleanup here before we go any further. I don't like using the lib function, the lib structure like this. Actually, I have a naming scheme in mind. I want to use this if structure, and database is an actual library. So I'm going to leave it as a lib, but these others are interfaces. So I'm going to name them if. Close out all these old files so they don't confuse me. I'm going to export these as defaults. When you export it as default, you don't actually have to surround these with braces anymore. There, that's a little bit cleaner. That must be, yeah. Beautiful. Oh, one slight problem. I believe when yeah, you got to put a false in here. Otherwise it gets stuck in that loop. There we go. Don't need to print out that giant list anymore. And it's functioning, we should be good to go. We've got access to the server object and it's queued in the database, or cached in the database. Cool, thanks for watching. Next episode, I think we'll look at some more advanced logic.